everybody. This is Mrs. Snook with 6.3, Solving Systems Using Elimination. And this is going to be our third way to solve systems. And we can do that by adding or subtracting the equations to remove or eliminate one of our variables. So let's take a look at these two equations here. Equation 1 says 2x plus 5y equals 17, and equation 2 says that 6x minus 5y equals negative 9. And I want you to look carefully at the plus 5y and the minus 5y. If I add those two equations together, those 5y's are going to drop out and thus eliminate the variable y. So let's go ahead and do this. So 2x plus 5y equals 17. I'm just going to add our second equation to it. 6x minus 5y equals negative 9. So when I add them, I get 8x, 5y minus 5y, those drop out, and I get 8x equals 8, x equals 1. So now I've solved for x. All I have to do is go back into either one of those equations, plug in that x, and solve for y. Let's just go to the first equation. So 2 times 1 plus 5y equals 17. I'm going to get 5y equals 15 because I subtract 2 from both sides. Then I'm going to divide both sides by 5. And I get y equals 3. So my answer for this one is 1, 3. All right, now instead of adding these equations together, I'm going to subtract them. And the reason is, if you look at the y's, I have negative 6y and negative 6y. If I add those together, I get a negative 12y. And if I add the x parts together, I'm going to get a 2x. So here's what happens if I add. I'm going to get 2x minus 12y equals negative, let's grab a calculator here, 32 and 48, negative 80. So that has not eliminated any variables. That doesn't help us. So that's why in a case like this, I'm going to subtract instead. So here's my first equation, 5x minus 6y equals negative 32. And the way you subtract something is you change its signs and then add them. So my second equation is going to be 3x plus 6y equals 48. So what we've done here is just change all the signs. So to subtract, change signs. Okay, and so now that we've changed the signs on the second equation, we are ready to just go ahead and add them together. Those 6y's drop out, and I get 8x equals 16, x equals 2, and then go back, plug that 2 into either one of your equations. So I'm going to use the first equation, 5 times 2 minus 6y equals negative 32. So I'm going to get 10 minus 6y equals negative 32. So now my answer for this one is 2, 7. Okay, now this time, look at the equation. I can't just add or subtract. That won't work. But what I can do is if I look at these y's, so I have a 15y here and a negative 5y there. I can multiply my second equation by 3, and then check out what happens. So if I multiply this side by 3 and this side by 3, what I get is 21x minus 15y equals 51. Now I have a plus 15y in one equation and a minus 15y in the other. That's going to allow us to eliminate y. So negative 2x plus 15y equals negative 32. 21x minus 15y equals 51. So now I can add them like I did in our first example, and those y's go away. I'm going to get 19x equals 51 minus 32, 19. Then x equals 1. Go ahead and plug in. Negative 2 times 1 plus 15y equals negative 32. I'm going to add 2 to both sides. So I get 15y equals 30. Which gives us y equals 2. So now my answer for this one is x is 1, y is 2. So 1, 2. Okay. Now what happens if I need to multiply both equations? When I look at the coefficients, I don't see a way to multiply one equation to then eliminate a variable. So what I'm going to do is multiply both equations. Now we've been eliminating y. Let's eliminate x instead. So I have a 3x and a 4x. So if I multiply my first equation by 4, and then I multiply my second equation by 3, I'm going to get this. Remember to distribute, so I get 12x plus 8y equals 4. And then my second equation turns into 12x plus 9y equals negative 6. So now I can subtract those two equations, and my x will be eliminated. So remember to subtract. Change the signs on the second equation. So this is going to be a negative, this is going to be a negative, and this is going to be a positive. And I like to circle those signs when I change them. That way I know that I've changed them. Now I'm going to add. My 12x's drop out. And I get a negative y equals 10. So then y equals negative 10. Now I've got y. Plug that in and find x. I'm just going to go back to our original equation, the first one. So 3x plus 2 times negative 10 equals 1. So 3x minus 20 is going to equal 1. Add 20 to both sides, I get 21. X equals 7. Okay. Now we're going to look and we're going to find the number of solutions. So take a look at our first system. I'm going to do this one first. I have 2x plus 6y equals 18 and x plus 3y equals 9. And when I look at the coefficients on the second equation, I notice that if I multiply by 2, I can get the same thing as the first equation. So let's multiply both sides by 2. and that's going to give me 2x plus 6y equals 18. Now compare those equations. They're identical. So what happens if I subtract one equation from the other? Now I'm going to change signs. And then I'm going to add. X's drop out, Y's drop out, so I get a 0 on the left, and I get a 0 on the right. I get 0 equals 0. So what that means is I have infinitely many solutions. Because 0 equals 0 all the time. That is always true. Now let's look at our other one. I have a 2x plus 5y equals 7. Sorry, negative 2x. And a negative 2x plus 5y equals 12. Let's go ahead and subtract them. So I'm going to change signs on the second one. This becomes a positive, that becomes a negative, that becomes a negative. Now I'm going to add them. 2x minus 2x is 0. 5y minus 5y is 0. 7 minus 12 is a negative 5. So I get 0 equals negative 5. That's not true ever. So therefore, this one is a no solution. All right, that's it for today's video. Thank you for watching and have a fantastic day.